So I may vary the speed of the motor by shifting the positions of the brushes, or very slight variation in this respect by disturbing the relations between the rate of impressed impulses and the variations of the circuit of high self-induction and to which they are directed, causes a marked departure from the condition of resonance and a corresponding reduction of the amount of energy delivered by the impressed impulses to the apparatus. A similar result may be secured by modifying any of the constants of the local circuits as above indicated, for example in figure 2. Try to go to figure 2 now. So in figure 2 you will see that there's something new here. That is a regulating device in the form of a piece of metal which goes in and out of the coil, which will vary the self-induction. So the choking coil E is the of high self-induction, the coil, is shown as provided with a adjustable core N, by the movement of which into and out of the coil, the self-induction and consequently the period of the circuit containing such coil may be varied. As an example of the way in which the discharge circuit, or that into which the condenser discharges, may be modified to produce the same result I have shown in figure 3. An adjustable self-induction coil R in the circuit, with which the condenser, by the adjustment of which the period of vibration of such circuit may be changed, and we go over to figure 3, and there we see this another induction device which will indeed regulate the period of discharge of the condenser here. Okay, furthermore, so an adjustable self-induction coil R in the circuit with the condenser, but by the adjustment of which the period or vibration of such circuit may be changed. The same results would be secured by varying the capacity of the condenser. But if the condenser were of relatively large capacity, this might be an objectable plan, and a more practical method is to deploy a variable condenser in the secondary or working circuit as shown in figure 3. In figure 4, and here you will see two plates. Okay, so the output is basically a condenser, and on there will be still a working circuit with devices, okay, to use the obtained electricity. So in figure 4, as the potential in this circuit is raised to a high degree, a condenser of very small capacity may be employed, and we still speak about this capacitor here. It may be well, very inexpensive and very small. By the way, it will probably be a capacitor bank, okay, because the voltage will be so high here that your capacitor will be too expensive if you buy a single capacitor of high voltage. So you can put several relatively high voltage capacitors in series to secure your circuit so that you don't blow them up. I have illustrated. So let me repeat: a very intimate and closely connected to the so I will repeat: as the potential in this circuit is raised to a high degree, a condenser of very small capacity may be employed, and if the two circuits, primary and secondary, are very intimately and closely connected, the variation of capacity in the secondary is similar in its effect to the variation of the capacity of the condenser in the primary. I have illustrated as a means well adapted for this purpose two metallic plates S adjustable to and from each other and from each other and constituting the two armatures of the condenser. I have confined the description herein to a source of supply of direct current as to such the invention more practically applies, but it will be understood that if the system be supplied by periodic impulses from any source, which will affect the same results, the regulation of the system may be affected by the method herein described. So you can use alternating and direct current, and because you work with this circuit controller, you will anyways recreate your pulsing, your timing deal, and determine how to discharge, at what frequency, at what time interval you will discharge it through the working circuit. Okay, what I claim is the method of regulating the energy delivered by a system for producing of high frequency currents and comprising a supply circuit, a condenser, a circuit through which the same discharges, and a means for controlling the charging of the condenser by the supply circuit and the discharging of the same. The said method consisting in varying the regulation of the frequencies of the impulses in the circuits comprising the system as set forth. 2. The method of regulating the energy delivered by a system for producing or production of high frequency currents comprising a supply circuit of direct currents, a condenser adapted to be charged by the supply circuit, and 2. Discharge through another circuit the said method in varying the frequency of the impulses of current from the supply circuit as set forth. 3. The method of producing and regulating electric currents of high frequency which consists in directing impulses from a supply circuit into a charging circuit of high self-induction, charging a condenser by the accumulated energy of such charging circuit, discharging the condenser through a circuit of low self-induction, raising the potential of the condenser discharge and varying the relations of the frequencies of the electrical impulses in said circuit as herein set forth. Well, it's nice to say that you will have so much regulators. You have your flyback, right? On your flyback you can have your driver with a frequency control. It's not so difficult to make. You have a circuit controller with a regulating speed control. You have your high induction coil there. You can see it in figure 1, which or figure 2. You will see in itself also a regulating device. And of course this will determine the period of discharge of your condenser, and there's another option to have an induction coil here, which is basically an induction device. And then of course you want to have everything in resonance, so you check the length of your wires, especially the primary. So this should be a division of a multiplication of your primary, and your primary is also in resonance with your secondary. All divisions in length of wire. And normally it probably is so easy as that, but the nice thing here is that you don't have to have measure equipment, because you can everything do yourself by adjusting the parameters. And if we understand it a little bit, the circuit, then we can try to, well, we can start with the beginning, okay, frequency, and then see what goes best. And like Don Smith also says, when you have it in frequency, when you have it in harmony, when you have it in resonance, you have sparks. So you can first build this one and check your sparks, and well, you get there.